Hello, dear students. Today we have Proposition 18 of Book 3. 18, Book 3. If a straight line touches a circle, and from the center of that circle, a line be drawn from the center to the point of contact where the straight line touches the circle, that straight line so drawn will be at right angles to the tangent. Remember, we use that word tangent for a straight line which touches a circle. That's called a tangent. Here we have a circle. Here we have the center. I'm going to redo the center because it doesn't quite look like it's in the center. And here we have a line, the red line, touching the circle. That's given. Thus, it is required to show that the straight line drawn from the center to the point of contact will be at right angles. Okay? So let's say this is our point of contact. And let's draw this line. It's required to show that this line, so dropped, is necessarily at right angles. We're going to do a reductio. Say it's not at right angles. So here you have a straight line and a point not on it. We know we can, from that point, we can drop a line perpendicular to that line. So let's do it. Now, this, say, is perpendicular. Remember, we're doing a reductio, so it's going to look weird. Okay, so here you have a triangle, and this one is supposed to not be at right angles, that this one is at right angles. And we know in every triangle that the greater angle is subtended by the greater side. We also know that in every triangle, the three angles added together are equal to two right angles. So if this is a right angle, this and this are equal to a right angle. That is to say, each one of them is less than a right angle. Well, if this is a right angle and this is supposedly less than a right angle, now we can invoke that other thing we learned, and that is, in any triangle, the greater angle is subtended by the greater side. Remember, this is not going to fit with your imagination because we're doing a reduction. So this, being a greater angle than this side is necessarily greater than this side. Because in any triangle, we've proven that in any triangle, the greater angle is subtended by the greater side. Greater angle, greater side. Less angle, lesser side. Okay? So this is greater than this. But this is equal to this part. This dashed line and this green line are radii of this circle. Therefore, they are equal. Okay? So if this is equal to this and this is greater than this is also greater than this. Said another way, if this is equal to this and this is greater than this is greater than this. But it's also less than this because it's a part of it. So here, that is to say, it's not greater. So here you have this line being greater than this and not greater than this at the same time in the same respect. Boom! Absurd. So everything was true and good and beautiful and logical about our argument here. So the first thing must have been a mistake. That is to say that this is not at right angles. If it's false to say that it's not at right angles, it must be at right angles. Okay? So we have shown then that if there be a circle and a tangent to that circle and a line be dropped from the center of the circle to the point of contact of the tangent, that line so dropped will be at right angles. Quod erat demonstrandum. Thank you. Bye.